Greetings, AP Physics 1 students. Welcome to Module 1 of your summer assignment. Now, the purpose of these modules is not to give you busy work. It's not to teach any physics. The purpose of these modules are strictly to make sure you have the skills that are necessary to be successful in Advanced Placement Physics 1. Specifically, we're looking at math, graphing, and other scientific skills. So if at any point during these modules you're thinking like, why am I wasting my time watching something about significant figures? I just took chemistry. I know all about them. That is totally fine. Skip right to the end of the section, either the quiz or if there's an assignment, and do that. Skip the practice because you don't need it. That is totally fine. These are strictly meant to make sure that you have and are set up for success in Advanced Placement Physics 1. So with that, we'll get into our first module, which is on significant figures. Now, what are significant figures? We're going to talk more about this in class for about a grand total of about 15 minutes. And that's different from your chemistry class, where you probably spent the whole first semester learning what sig figs were and were bored out of your mind and were like, when we're actually going to teach some chemistry. That is correct. So in that class, you learned that significant figures are really the number of digits in a value. You might have considered it the least precise known number. But what we're talking about numbers really from a measurement, and they tell us how accurate our measurement is. So significant figures, if I were to ask you where they come from, a lot of times people say, oh, they come from chemistry. Well, there's a reason they come from chemistry, because in chemistry, when you're looking at something like a graduated cylinder, right? In a graduated cylinder, this guy, for example, goes up to 500 milliliters, and it's got the little marks in between, and you can approximate to another value, right? So there's a lot going on. If I use an Erlenmeyer flask, for example, though, it looks something like this. I guess I probably should have. Hey, that's not bad. This might be a 250 milliliter Erlenmeyer flask. And what that means is that I have 250.00 milliliters. How do I know that it's this amount of numbers? Because that's what an Erlenmeyer flask is, right? That's just what it is. And there's like a line that you fill it up to. So my definition of sig figs is how accurate your tool is. And perhaps I can explain that with a little quick demonstration that we'll also probably do in class. I have what's known as a four-sided meter stick, and this is the coolest meter stick that I own. And for some reason, people like to use this, but it's kind of useless. Three of the sides. So I have a 3-hole punch here, and it's just kind of chilling out on my lab counter. And my question is, how long is my 3-hole punch? And here's the reality. With the side that's up, this 1 meter side, all I know is that this length is 1 meter. Now, as a scientist, you have the ability to say, okay, well, that's 1 full meter. In my head, how am I doing? 1, 2, 3, 4, whatever. I did that terribly. But in my head, I can break this up into tenths. As a scientist, I have the ability to say to the nearest tenth. It's either 0 meters, 1 meter, or it's a tenth of something there. So maybe I'd say, oh, it's about this far. I can call this 0.3 meters. That is as accurate as this tool is. Why? Because it's a terrible meter stick. Okay, well, let's look at my next meter stick. So here is the next side of this meter stick. And this meter stick now is divided up into decimeters, which means that it tells me where 0, 0.1, 0.2, 0.3, 0.4, it tells me where those are. And I know that because the tool is correct. But again, I have the ability as a scientist to say it's one of those, and then I can break it up, or I can approximate to the next tenth. So what am I thinking here? As I'm looking at this, I know it's more than 0.2. It looks like it's right about 0.3, and I'm going to say it's just shy of 0.3. So I can approximate this value to, it's 0.29 meters. Now, if you recall, my last measurement was 0.3 meters. So I went from 0.3 to 0.29. And why can I do that? Because that's how accurate my tool is. The more accurate my tool is, the more decimal points I get. So I went from my initial 1 sig fig. Now I have 2 sig figs. Let's go to the next side. So as I'm zooming in on this next side, I can see that it is like just shy. So there's 29, there's 28. Now we're going by centimeters now, and I can approximate to the next tenth, which means that I can approximate to the tenth of a centimeter. And right here, I'm looking at about 0.28, and I can approximate the next tenth. So I'm going to say 288. I'm going to call that 288 meters. Okay, so I approximated to the next tenth. Now I have 1, 2, 3 sig figs. I have numbers that I know to a certain precision. Now this last one, this 288, that's my floating one. That depends on my approximation. But as you can see, I am now up to 3 numbers. So I started with 0.3, then I was 0.29, and now I'm 0.288. So I'm adding, every time I get a more accurate tool, I'm adding a sig fig. So let's go to our last one. Now I have the millimeters showing. I'll be honest with you, I can barely read this picture. The moral of the story is, though, I can go 0.2885 or whatever. So I can approximate this last tenth, which is going to be the tenth of a millimeter, and that gives me 4 digits. So the number of digits that I have that are reliably known are significant figures. So that's where sig figs come from. Now, what do we do with them is something you spent a ton of time in chemistry doing, so we're going to talk about that real quick. So there are rules whenever I have significant figures. If I'm adding, subtracting, multiplying, dividing, there are different rules. So if I'm multiplying or dividing, I have 3 sig figs and 2 sig figs. The answer should have the lower of the 2 amounts of decimal points, or the lower amount of significant figures. So in this case, 5.7 has 2 sig figs, so my answer can only have 2 sig figs. If I am adding or subtracting, the answer should have the lower of the 2 decimal points, not how many decimal points we have, but this 106.6, that's only known to the 10th, 18.54, that's known to the 100th. My answer can only be known to the 10th. You notice here that it's 4 sig figs and 4 sig figs, but my answer is governed by my least precise known value. So if I go 5 meters and 50 centimeters, right, which one's my least precise known value? Now, there are some other exceptions. So that's just when we're adding and subtracting, but sometimes I have what's called exact numbers, and I like to call those numbers ambiguous. They're kind of confusing, and when we use them in calculations, we ignore them. So some of our examples are pi. So pi is a precise number. It has an infinite amount of decimal places. So how many sig figs does it have? Well, it's infinite. So let's just ignore it. Let's not use it in our calculations. And then I like to throw this one out there. What about the number 10? How many sig figs does 10 have? Well, if you've taken chemistry and you say, well, and I'll talk about this in a second, but there's not a decimal explicitly expressed, so the number 1 is your only sig fig, so it's got 1 sig figs. And I'm like, well, if I have 10 cans of Pepsi, how many sig figs is that? Well, it's infinite. I know it's 10. It's 10.0000, and there's an infinite number of zeros. So I tend to ignore those in my calculations. So there are some rules for zeros, and we will quickly, again, go over these at the beginning of the year. Zeros have 4 different rules. If they are bounded by non-zero digits, they are significant. So this first example right here, that's only 1 sig fig. Those other 2 zeros, they are not bounded. Right here, that's 3 sig figs. Here, this first one is not bounded. The second one is. That's 3 sig figs. Zeros before the first non-zero are never significant. So 1 sig fig. These 2 zeros right here, not significant. 3 sig figs. These 2 zeros are in between numbers, so that is 4 sig figs. If a decimal point is explicitly expressed, all zeros are significant. And again, this is a little ambiguous, but technically This first 1,000, that's only 1 sig fig. This second 1,000, that's 4 sig figs. This 10.00, that is 4 sig figs. All of these zeros after the decimal point are significant. And then finally, we have a non-zero, and all of these are significant. So that will be 7 sig figs. And finally, if a decimal point is not explicitly expressed, we do not consider the zeros to be significant. So this one, technically only 2. This one, again, it is explicitly expressed. So this is actually 5. This one, that's only 1. And this one, that's only 3. Okay, so there's some confusing rules. If you've taken chemistry, you're very familiar with this, but those are the rules for significant figures dealing with zeros. So I got a quick, there is a practice worksheet. Again, this practice worksheet is optional. If you want that extra practice, awesome. If you don't, awesome. So here I'll do these 6 little examples. 6.001. These zeros are bounded by non-zero digits, which means that this has 4 sig figs. 0.0080. These zeros preceding the first non-zero are not significant. They are what I like to call placeholders. I could rewrite this in our next section, which we're going to talk about as scientific notation, as 8.0 times 10 to the negative 1, 2, 3. And look at how many numbers I have here. 2. Well, that's this. 2 sig figs. All right, 206,000. Again, no decimal point, so these are not significant. So that's 3. 27.00. That is explicitly expressed. That is 4 sig figs. Here I have pi. Again, pi, some people might say 1, some people might say infinite. I would say it's ambiguous. Who cares? It doesn't affect our calculation. And finally, I have some zeros bounded by non-zeros. That one should be pretty easy. That is 5 sig figs. So in AP Physics, where does that land us? Well, in chemistry, you might have gotten docked off points if you didn't have the correct number of sig figs. And that's like your whole first unit is like sig figs and stuff. And you take quizzes and tests and stuff just to make sure that you can count numbers. Well, congratulations, you've graduated to AP Physics. We do not stress sig figs. The only exception is you shouldn't carry everything that's in your calculator, right? So at the end of the problem, if you're solving something and it's 19 numbers long, please don't plug in 19 decimal point numbers or numbers after the decimal point, right? If your calculator says 19.8743 017, don't write that down. Write down 19.87 or whatever you're comfortable with. Now, in my solutions, sometimes it'll say 20. Why does it say 20? Maybe I only have 2 sig figs, right? And this is 20, and that'll give me the right number of sig figs. In reality, though, in AP Physics, we don't care. And we actually do some other stuff where we don't plug numbers in. We do what's called solving symbolically, and we'll talk about that later. Oops, symbolic. Yes, close enough. Solving symbolically, we'll talk about that later, where we plug in, if we have to manipulate our equation, we'll plug it all in at once, and we'll get a lot less round-off error. So that is it for Module 1, Significant Figures. There is a practice worksheet, and then you will have to take a quick quiz on sig figs, and that will be all. Good luck. Let me know if you have any questions.